Good morning, I am Renu Sharma, Assistant Professor EC Department. Today I am going to start with the next part of this subject, that is wireless and mobile communication. The topic of today's lecture is Introduction to Signals. So, we will discuss introduction to signals because before starting with in detail what is mobile communication, we have to discuss that how the information will be transmitted from the transmitter to receiver. Then continuous time signal is there and discrete time signal. So, introduction to signal, a signal is the function of one or more independent variable that carries some information to represent a physical phenomena. Now, that physical phenomena can be a ECG signal, can be a EEG signal. So, basically a signal is a continuous time signal, it can be discrete time signal. So, there is one independent variable and there is another dependent variable. So, in case of this independent variable, let us say I am going to show a signal with this x t or I am going to show a signal with this x n. So, this is an example of continuous time signal which is denoted by this round bracket, and this is the parameter that we have seen, this is t. Now, this is denoted by a square bracket and this is denoted by n, which is going to show that it is a discrete time signal. So, continuous time signal and discrete time signal, these are the two types of signal which will going to represent any physical phenomena. So, that is about the representation of signal. So, this is dependent and this is dependent variable and this is independent variable. The term inside the bracket, whether it is a square or round, the term is independent and otherwise it is dependent variable. Now, the continuous time signal that has a value for all points in time. So, it is a function of time which is written as x t, because the signal x is a function of time, commonly found in the physical world, that is example is speech. So, that is a continuous time signal. Now, you can see over here, this is continuous in nature. What do you mean by continuous? Continuous means firstly it is denoted by this x t and it will be defined at every point of time, whether it is here, everywhere, it will be defined at every point of time. So, that is a continuous time signal. It is displayed graphically as a line. So, that is a example of continuous time signal. Now, next is discrete time signal, that has a value for only specific point of time. So, this is an example of discrete in nature. It is denoted by x n and it is defined at 1, 2, 3, 4 and 5. So, this is how the information will be displayed at discrete point of time. So, that is an x n signal. So, the function of sample value n, it as written as x n, which is a difference between continuous time signal and discrete time signal. Then it is often called as a sequence, because continuous is known as continuous signal and discrete is known as a sequence. Then commonly found in digital world, which is denoted by this wave file or MP3 signal. It is displayed graphically as individual values called a stem plot. So, that is a discrete time signal. Now, this continuous time signal, this is a diagram which is showing that how this continuous time signal is plot. It is x t is equals to e to the power minus 0.1 t sin 2 by 3 t. So, this is nothing, it is a continuous time signal, because you can see over here that it will be defined at every point of time. It is continuous in nature, whereas in case of discrete signal, it is discrete in nature. It is defined at 0, 1, 2, 3, 4, 5, 6, 7. So, it is defined at discrete point of time. So, this is the discrete time signal. Now, how this continuous time signal is converted into discrete time signal. So, for the first step to convert this continuous time signal into discrete is the sampling. So, the sampling will be performed. Now, the discrete time signals are often obtained by sampling continuous time signals. So, this is a continuous signal, this is a discrete signal which will be sampled at discrete point of time. So, this will be sampled at discrete point of time and the signal will be discrete in nature. So, this is how the information will be transmitted, this is how the sampling will be done. Now, these are from here I am going to discuss different signals. Now, first one is the unit step signal. What is unit step signal? Now, this unit step signal, this is a shifted version of unit step signal, which is denoted by this u t minus a, that is a shifted version shifted at amplitude a. Its amplitude is 1 because this is 1, which means it is 1 u t minus a, that is the shifted version of unit step signal which is shifted by this a. Then there will be a signal that is denoted by u t plus a, which is shifted to minus a, because if you put t plus a equals to 0, then t will be equals to minus a, which means the signal will start from minus a. So, minus a will be from the left hand side of this origin. So, this will start at minus a and the amplitude will be 1. Now, next will be u a minus t. Now, when you put a minus t is equals to 0, a will be equals to t, which means it is time shifted version and it will be positive side. So, from the for this one it will start at a and it will be to the left hand side, it will not to right hand side, it will be to the left hand side, this is correct one. Now, next is u minus a minus t, which means minus a minus t will be equals to 0, t will be equals to minus a, which means it will start at minus a and it will be at the left hand side. So, this is also the reversed version at the origin. So, these are the different unit step signals. Basically, unit step signal is a signal which will extend, which will start at 0 and it will extend up to infinity and its amplitude is 1. So, that is why it is named as unit step. Whenever any signal is having this value unit, it means it is equivalent to its amplitude is equals to 1. So, you can see in every example its amplitude is 1, 1, 1 as well here, this will also be used as here, and these are the shifted version of signals. Next is unit ramp signal. Now, this is related to unit step signal also. There is a rule, that is delta t, then u t, and this is r t. So, delta t is nothing, it is the impulse function. This is nothing, this is unit step, this is ramp signal. This is how the information will be transmitted. It is the integral, which means integral of this signal is equivalent to this one, integral of this one is equivalent to this one, and the reverse part is the differentiation, d by dt and d by dt, which means differentiation of this r t is equivalent to u t and differentiation of u t is equivalent to delta t. So, that is the impulse function. Now, the unit ramp function is the integral of the unit step function. It is called the unit ramp function because for the positive t, its slope is 1 amplitude unit per time. So, this is the ramp signal, its amplitude is equivalent to 1, its to the time it will be equivalent to 1 and it will be extended over here. So, this is a unit ramp signal. Now, next is representation of the impulse function. What is an impulse function? Impulse function is basically used to is being represented by this diagram. You can see it will be extended towards infinity, but when a unit term is included with this one, that is unit impulse, which means its amplitude is restricted to 1 unit. Likewise, here also this is the shifted impulse of amplitude, that is of 5, which means its amplitude is 5 and it is shifted version. So, here two operations are used. First, the amplitude is has changed from unity to 5 and it is a shifted version. So, it will be demonstrated at 1 only. So, the area under an impulse is called its strength or weight. It is represented graphically by a vertical arrow, and impulse with a strength of 1 is called as a unit impulse case. So, this is the representation of the impulse function. Next is properties of the impulse function. So, these are some of the properties of the impulse function, like you can see over here. First one is the sampling property, which says that when any signal that is denoted by g t is multiplied or sampled with the shifted version at t minus t naught, means the delta function is present at t naught, then its value will be shifted version of that signal, which is demonstrated at t naught. Secondly, for the scaling property, when delta a t minus t naught is there, then it will be 1 divided by mod a, and it will be delta t minus t naught again, which means that the amplitude has been presented at 1 upon mod a, which is the amplitude. It can be a can be any integer value from 1 to infinity, it can be any integer value, it can be negative also. That is why we are using this mod sign, that so that it will be considered as a positive value. Now, next is the replication property. What is the replication property? As you can see over here, this is the convolution. When we are convoluting the input signal with this delta t, that is the impulse function, then at the output we are getting this function again without any change in the amplitude, without any change in the time. So, that is the property of the replication, that is the replication property. Next one is the Signum function. In case of this Signum function, when it is present at t greater than 0, its amplitude is equivalent to 1, at t is less than 0, its amplitude is equivalent to minus 1, and at t is equals to 0, its amplitude is 0. So, that is why it is written over here, this is a Signum function, it is closely related to this unit step function. Means this is nothing, these are the unit step function if you consider over here, if you consider to the left hand side, and that is why it can be written as 2 u t minus 1. So, that is the relation between Signum function and the unit step function. This is the precise graph, and this is commonly used graph that we are using over here, plus 1 and minus 1. Now, next is rectangular pulse or gate function. So, this is a rectangular pulse that is denoted by delta a t, which is equals to 1 upon a, mod t is less than a by 2, which means that t is from minus a by 2 to plus a by 2. Now, a is nothing, it is the parameter, you can say this is the parameter, or this is a is an alphabet. So, this is nothing, it is a parameter on an alphabet which will be extended from minus a by 2 to plus a by 2. Now, next is 0. So, t mod is greater than a by 2. So, that is the property of delta a t. Now, you can see over here that if this delta a t will be extended from minus a by 2 to plus a by 2, and its amplitude is 1 upon a, that it will extend, that is minus a by 2 to plus a by 2. So, that is the property of your delta function. So, that is a rectangular pulse or a gate function. So, whenever there is an input signal which is present over, which you want to modulate, which you want to transmit, you can transmit a gate function, means a signal which will be extended from minus infinity to infinity. Let us say this is the diagram waveform. Power, let us say an example of power spectral density, which is extended from minus infinity to infinity, and its amplitude will be n naught by 2. So, this is a nothing, it is the power spectral density of white noise. Okay, so, this is the power spectral density of white noise, and if you want to process that signal, then you have to definitely pass it through a gate function, and that gate function can be used by this one, that is the power spectral density of this white noise, and its amplitude will be n naught by 2. So, this is the rectangular pulse. Next one is the unit triangle function. Now, unit triangle function, if you see, it will be made up of two ramp signals, because if you can see that ramp signal is somewhat like this one, which will start from 0 and it will be extends up to infinity. So, that is a ramp signal. This is the shifted version. If you are going to shift this signal from minus 1, this is also a ramp function. So, this is one ramp function, this is the time reversed ramp function. So, this is made up of ramp function only. So, triangular pulse whose height and area are both 1, but its base width is not is called as unit triangle function. The unit triangle is related to the unit rectangle through an operation that is known as convolution. So, you can convolute that particular signal. Because the integration of the unit step signal will be a ramp signal. So, that is why it can be related to the unit step signal also. So, that is about the unit triangle function. So, this is these are the various functions, various signals that you have seen. I am going to show you some of the properties related to this impulse function also, like 3-4 points that you have to keep in mind related to this impulse function. Like first thing is that area under the curve is unity when we are talking about unit impulse function. So, area under the curve will be unity. Second point that you have to consider is height extends to infinity if we are not considering unit impulse function, but if you are considering unit impulse function means you have restricted the height to unity, that is unit, that is 1. So, the amplitude in that case will be 1. So, these are the two properties related to the impulse function. Another thing is that whenever we are processing a signal, whenever we are modulating, when we in case of digital modulation, let us say pulse code modulation or ASK, FSK, PSK, then we have to multiply the input signal with a carrier signal. In that condition, in that situation, impulse function comes into the picture, where you have to multiply the input signal with a train of impulses. This is known as train of impulse function, and in this case the width of this pulse, the third property is width tends to 0. Width tends to 0, which means in any case the width of every pulse will be tau. So, in this case tau tends to 0. So, this is known as the train of impulse function, and you have to multiply this train of impulses with the input signal, so that the signal will be performed as a convolution and you can modulate the signal. So, it can be written as P t minus k t from summation k is from minus infinity to infinity, and t is capital T is nothing, it is the sampling time. So, this is how you are going to represent the train of impulse function. Train of pulses is also there, that is a kind of signal which will be represented by these impulse functions, but its tau does not tends to 0, it has a value, that is pulse is having a width that is denoted by tau. So, train of pulses will be there and train of impulses will be there. Next is the unit ramp signal. We have discussed already the unit ramp signal, why we are studying this unit ramp signal. So, this is called as a unit ramp signal, because whenever you want to calculate the slope of any function, so you can calculate from here only. So, that will be x 1 comma y 1 and its value will be x 2 minus y 2. So, this is a very simple formula to calculate the slope of any function, that is y 2 minus y 1 upon x 2 minus x 1, which is equals to y upon x. So, this is nothing, it is how you have to calculate the slope of this particular signal. So, this is about the 1 amplitude unit per time, that is how you have to calculate the slope of this signal, that is y 2 minus y 1 upon x 2 minus x 1. So, if you are plotting any signal, you can calculate the slope, so that you can find out the information from that particular signal, and the differentiation of this ramp signal will be equivalent to this unit step signal, and the differentiation of this unit step is equivalent to the impulse function. So, this is about the ramp signal, which is of very much in use when we are talking about the triangle signal, when we want to calculate the slope of any signal. Likewise, we have discussed about the unit step signal also. Unit step signal is one of a you can say very basic function, very basic signal, which has a value which will be demonstrated by u t minus a. U t minus a means it is a shifted version of the unit step signal, which has an amplitude extended from a and it will extends up to infinity, and its amplitude is equivalent to 1. And in this case also when u t plus a is there, so it will starts from minus a and it will extends up to infinity. So, this is the unit step signal. Next one is u a minus t, again it will be a reverse time reversed version of the input signal, and it will extends towards minus infinity, and it will start at a. In this case it will start at minus a and it will extends up to minus infinity. So, this is about the unit step signal. Then sampling is done. So, this procedure is nothing, it is a part of this ADC, that is analog to digital converter. ADC, first step is sampling, next step is quantization, and the last step is the encoding. So, these are some of the 3 steps, these are the 3 steps, basic 3 steps to of ADC, that is analog to digital converter. That is what it is done over here. It has converted, this is the first step, that is sampling, which has converted the continuous time, continuous amplitude signal into discrete time continuous amplitude signal. So, this is how you have converted this continuous time, continuous amplitude to discrete in time, continuous in amplitude signal. So, this is the sampled continuous time signal. This is a MATLAB plot of the signal as an example. So, we have seen over here, which has a value extended from minus 0.5 to 0.8. Minimum value is minus 0.5 and maximum value is 0.8. So, this is the sampled version. Now, there are different types of samplers which are available, like sample and hold circuit, or different types of samplers are there. Natural sampling is there, flat top sampling, ideal sampling. These are some of the waveforms which are used to demonstrate this sampling signal. Sampling, after sampling, this discrete in time continuous amplitude signal is converted to quantization. Using quantization, it is converted to discrete in amplitude signal. So, this is how this discrete in time, discrete in amplitude signal looks like due to with the use of this quantization, and encoding will be done, which will convert it using 1-0 information. So, in this one, this is discrete signal. So, in this lecture we have discussed about introduction of signals, because every information you are going to transmit, it is terms of signals. It can be analog in nature, it can be discrete in nature. So, that will be discrete in time or continuous in time. So, sampling will be done. Discrete time signals are often obtained by sampling continuous time signals. So, sampling will be done. Then this is a unit step signal, which has an amplitude equivalent to 1. Then unit ramp signal will be done, that is x 1 y 1 to x 2 y 2, and that will be used for the purpose of transmission. This is unit triangle signal. So, these are the references that you can consider for this lecture. Thank you.